9.4 rational and irrational numbers. So these are all considered real numbers. On your vocab, irrational number is a number that cannot be written as a quotient of two integers. So basically, it can't be written as a fraction. Excellent. Real numbers consist of all rational and irrational numbers. Now, written down here, I have them separated for you. In order for anything to be, a number to be rational, for it to be rational, it has to be a perfect square. If it's a perfect square, it's rational. Now, on your homework today, I'm not going to make you write it out, rational and irrational. If you want, you can just use the capital R. So if it's a perfect square, yep, it's rational. If it is a fraction, automatically we know it's rational. All integers, that means whole numbers and their opposites. And then all terminating and repeating decimals are rational. Repeating decimal, 0.33333, so you go 0.3 with the bar notation over the 3, that's rational. Terminating, 1/4, turn that into a decimal, you get 0.25. Stops, it terminates. That is considered a rational number. Irrational, the best example of irrational is pi. There's no rationale behind it. I have no clue. You get it. 3.1415926535, blah, 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 blah. There's no, it doesn't repeat. It doesn't stop. It doesn't terminate. It's totally irrational. So if you see pi, or 3.14, you know, it represents pi, irrational. Basically, that explains if it's non-repeating, it doesn't repeat, and it doesn't terminate. Any decimals that don't terminate or don't repeat, they're irrational. And then finally, obviously, if it's not a perfect square. Because if it's a perfect square, like the square root of 25 is what? 5. So is the square root of 25 rational or irrational? Rational, because it's a perfect square. If it's not perfect, you put I for irrational. Let's practice. All right, example 1, it tells us to classify real numbers. Looking at it, what is that? 7/10. That is a fraction. Excellent, a fraction. So just by knowing that it's a fraction, we can name it. Rational or irrational? Rational. Rational. So what type is it? It is rational. Capital R. How about this one? 2/9.
Rational.
Rational. Why do you know that? How do you know it's rational?
It's a fraction.
Again, it's a fraction. Now, be careful. Sometimes you might have the square root of 7/10. All right? If it's not a perfect square, then it's not rational. And we'll get into those a little bit later. But sometimes the fractions are inside the radical sign. You're going to have to determine. Now let's look at this one. The square root of 5. Is that a perfect square?
No.
No. What do you get when you have the square root of 5?
2.23606.
5 square root. Wow, look at that. It's not perfect. It ends up with a decimal. It's not perfect, therefore, no. So we label that I. It is totally irrational. It's not a perfect square, it's irrational.
Well, that number stops, so shouldn't it be irrational?
It doesn't terminate, it just kind of run out of room.
Oh.
And there's no repeating. Yep, there's no rhyme or reason to it. All right, now that we've determined which ones are rational and which one is irrational, let's see if these match what we talked about in our vocabulary. 7/10 as a decimal. 7 divided by 10 on your calculator is? 0.7. What kind of a decimal is that? It is a?
Is it terminating?
Excellent. Terminating. Not terminator, but a terminating. It is a terminating decimal. 2 divided by 9. You're going to get?
Repeating.
0.222, which is 0.2 repeating. So we just said it. It is what kind?
Repeating.
Repeating decimal. Now, the square root of 5. 2.23606. And it kind of runs out of room on your calculator, right? Blah, blah, blah. Does it terminate? No. It is a non-terminating decimal. Does it repeat?
Nope.
No. So it is also a non-repeating, which makes it irrational. All right, now we take these numbers, and another part of your homework today, you have to compare real numbers. Now, just for today and on today's homework and assignment, if it says to put them on a number line, we're just going to skip over that part today. We're going to skip over the number line part. So say this was number 1. You'll rewrite it on your homework. You go number 1. The square root of 3, okay, I'm getting this, is what compared to 6 over 5? Less than, greater than, or equal to? How am I going to figure this out?
You get the square root of 3, and then you get a decimal, and then you divide, well, you get 6 divided by 5 to also make a decimal.
Perfect. So you're telling me to turn them both into
Decimal.
decimals. Exactly what I wanted to hear. So what is 3, the square root of 3?
1.732.
Okay, we're good. Usually if you stop at the thousandths, you're pretty good. You don't need to write anymore. And then 6 divided by 5 is
1.6.
1.2. Now just for practice, you don't have to do this on your homework, but is the square root of 3 rational or irrational?
Irrational.
This one would be irrational, wouldn't it? How about 6/5?
That's rational because it's a fraction.
Absolutely, because it's a fraction. Okay, that was just extra practice. But on your homework then, what are we going to put in here in the middle? Less than, greater than?
Greater than.
Greater than, so you're saying 1.732 is greater than 1.2?
Yep.
And remember, if you have to, you can always add zeros so you have as many.
Yeah.
But you can just look here. 7 is bigger than the 2. So this is bigger, gets 2 dots. This is smaller, gets 1. The greater than sign is correct. Questions on that one? All right, checkpoint. Number 1. Rational or irrational?
Rational.
Rational. Why?
Because it's repeating. Because it's repeating.
No.
Oh, okay, it's a fraction.
It's a fraction. Therefore, it is rational. Rational.
Irrational.
I or R?
I.
Why?
Because it's not repeating or not.
It's not.
Terminating.
Non-terminating.
It's not.
Terminating.
No?
It's not rational.
Oh, poor 7. You're not.
Perfect.
You're not perfect. It's not a perfect square. Sorry, 7. 49. Square root of 49.
It's rational.
Rational. Why?
Because it's perfect.
Woohoo, you're perfect. 49. And now, how about here? The square root of 2/5.
It's rational.
No.
It's rational.
Irrational.
Well, it's inside the square root here. So let's see. 2. Oops, clear. 2 divided by 5 equals
And then you have to do the square root.
0.4, right? Now that's in the square root, so you hit your square root. Is that a perfect square?
No.
So it is.
Irrational. It's not perfect.
Oh, correct. So you would write not perfect. Next page. Copy and complete the statement using less than, greater than, or equal to. So what does this turn into? A negative 1 point, I think I heard it. Yes, negative 1.5. And this turns into a negative 1.7 what? 3, good enough. So now, less than or greater than? Left hand, less than. Show me your left hand if you think it's less than. Show me your right hand if you think it's greater than. Right? Now it's negative. Right? It's negative, so it's kind of like opposite day.
Wow.
Lot of different hands out there. Okay? So pretend the negatives aren't there. We'll get rid of some of these confused hands that are kind of going up and down. They're not quite sure. Pretend these negatives were positives. What kind of sign would go in there then? It's easy. We would know that you would put a less than sign in there, right?
That's not right.
But these are negatives, negative 1.5 and a negative 1.73. So it's going to be the opposite. All right, because negative 1.5 is closer to 0 than the negative 1.73. All right. Now this one. What's the square root of 10?
3.16.
So we have 3.16, and then we have 3.5. Less than or greater than? Like that? Correct. All right, again, for now, just for today, we're not going to work with the number line today. We need to order the numbers from least to greatest. And you take these original numbers here, and we order them. Well, first, order them, but what are we going to have to do first before we can order them? Bingo, thank you. So, oh, that one's done for us already. It's 5.9. Now, how do I turn that one into a decimal?
You have to do the square root of 5 and then
Times it by 5.
Excellent. Take the square root of 5 and I get this, and now take that times
3.
the 3, and I get what? 6.708. I'm going to stop after the 1,000. All right, now let's put 7 over 5, or 27 over 5. My bad. 27 divided by 5 equals. Is that what you get? 5.4. And the last one, the square root of 35. 916. Now, just for fun, let's see where I'm at here. Would this be rational or irrational? 5.9.
Rational.
Rational. Why? Because it terminates. How about this one?
Irrational.
Because it went on and on forever, didn't it? How about this one?
Rational.
Because it terminated. And how about this one?
Irrational.
It's irrational because this is not a
Perfect square.
square. Ooh, you guys are getting this. Good job. All right, now let's order them. What is my smallest one?
27.
Remember, you can add some zeros if you need to. So, smallest one is what?
27 over 5.
And in decimal form, which one is that?
5.4.
So this is my smallest, you're saying?
Yep.
Next?
5.9.
Excellent. 5.9. Then we have,
5.9.
yep. And then finally, that one. Now you have to write your final answer using the original forms. So number 1, like you said earlier, 27 over 5, comma. Then we have 5.9 is my original here. And number 3, which was the square root of 35. And finally, number 4, which was 3 times the square root of 5. And there's our final answer from least to greatest. What if these were all negatives? Exactly. If these were all negatives, we would be completely backwards. So then if they were all negatives, all you'd have to do is list this one first, this one second, this one third, and this one fourth.
Where's the greatest?
And now we get to practice on a negative. So turn these all into decimals. Negative what? Square root of 21?
4.582.
negative 4.6,
Negative 4.
and negative 4.5, and last, negative what?
4.472.
Like that?
Yeah.
Alrighty. They're all negatives. So instead of basically saying from least to greatest, when you go negatives, like you were saying, you can say, well, let's just pretend we're going greatest to least, you know? So backwards say, which one is the smallest?
4.6.
4.6. Agree or disagree? So this is my smallest, even though if it were positive, it would be my biggest. Very good. Number 2. Next smallest.
5.8.
This one?
Yeah.
Uh-huh. The next biggest?
4.5.
Like that.
Yeah, and then the last one's 4.
And the smallest one, you're saying is like this?
Yeah.
Everybody agree?
Yes.
Everybody agree?
Yes.
All right, I wasn't sure. So then writing them in original form. Negative 4.6, comma. Negative the square root of 21, comma. Then what?
Negative 9.
Yep, negative 9 over 2. And then finally, negative 2 times the square root of 5.
This is what
Matt.
we have to write them like they were before.
Yep, always write them in their original form. Any other questions? This is cool. All right, this is just a little drop in the bucket of what CSI and police work can do. Here's an example of how you can use this in your everyday life, mathematics. Here's an example of speed, and you've all heard on the radio or the TV is there's an accident and they figured they were going about 75 miles an hour when they hit the approach or when they collided, you know. You ever wonder, how do they know? You know, nobody was there. How do you know how fast they were going? Squirrels don't talk. They're going to tell you. How are you going to figure that out?
The cop does that speed gun thing.
No.
Yeah, but there's no cops around.
Oh,
Nobody's there. But there's been many experiments done, and they've got all kinds of formulas and all kinds of good stuff to help you figure out how fast that car was going. Now, they don't say, this is just really minor, little drop in the bucket example, because actually they have different ones for, this is skid marks, but they don't say if it's on pavement or gravel or grass. They've actually got all kinds of those different formulas for all different scenarios. So this is just in general. Just in general, they're telling we can find the speed of the car by finding the square root of 27 times the length of the skid. So, speed equals the square root of 27 times,
98.
how far did that car skid in that accident? When
98.
it was, the skid mark was 98 feet long. Woo! That's a pretty good skid mark. All right, now the speed, what is 27 times 98?
2,646.
Awesome, that's what I got. 2,646. Am I done?
No, you have to find the square root of it.
Perfect. I want to hit the square root.
And you get 50.
And so the speed, and again, why do I write the little squigglies and not a straight equal sign? Approximately. So the speed was approximately, or about 51 point, they want us to round it to the nearest tenth.
51.4.
51.4 or 5?
4.
Alrighty, I agree with you. And we label that?
Cars. Skids.
Now I'm hearing it. What is it?
5 per hour.
Uh-huh.
Cars.
So, in that accident, they can estimate that the car was going approximately 51.4 miles per hour when it had its accident. Pretty cool. Any of you ever think about going into police, CSI, all these, yeah. Like I said, there's a little, just tiny little dust particle of all their knowledge that they can apply.
Really bad.
I would be the CIA.
No, really?